In an earlier film in this series, Introduction to Radioactivity was the title, I suggested how the subject of radioactivity might be introduced in schools without dogmatic assertion by the teacher or too many black boxes beyond the pupil's comprehension. In that film, I built on from the electrostatics with which the pupils were already familiar, using this model of an electroscope with a counter-electrode, which could be used for measuring very small currents. This is such an electroscope, and we introduced a radioactive substance as an ionizing agent. We went on to investigate various properties of the radiation, and the work finished with the introduction of the Geiger tube, first mounted on the electroscope, and then connected to a scaler as an automatic counting device. In this film, we hope to take the study of radioactivity further. And here's my colleague Vivian Robinson, who will suggest a number of experiments that might be done in schools once the initial work and the Geiger tube and the scaler have been understood. It's all yours.
Firstly, I would like to outline a series of experiments which can be done at an elementary stage to show that there are 3 different types of radiation. It's a matter of looking for evidence, for clues, and it's a nice piece of detective work that the pupils can do for themselves. I have here 4 different radioactive sources, labeled A, B, C, and D. And I'm going to use 4 different methods of detection. The simple gold leaf electroscope, the spark counter, a GM tube with a thin-walled end window connected to a scaler, and another GM tube without a thin wall end window, which we shall call a thick GM tube, connected to another scaler. Now let's try the effect of these 4 sources on our detectors. I'll charge the electroscope, bring up source A, it discharges it. It also affects the spark counter. But if I bring up a piece of paper between the source and the counter, clearly the radiation is stopped by the paper. Source A has no effect on either GM tube. Any occasional pulses recorded on the scaler are due to background radiation. Let's record those results. Source A discharged the electroscope, affected the spark counter, and did not affect the GM tubes. And the radiation was stopped by paper. Now let's try source B. It will discharge the electroscope, but only very slowly. No effect on the spark counter. With the thin-walled GM tube, we get a response. A piece of paper inserted here does not reduce the radiation. But this piece of perspex clearly does. With the thick-walled GM tube, nothing. Now let's record those results. B only just affected the electroscope, not the spark counter, the thin-walled GM tube, but not the thick. The radiation was stopped by perspex. With source C, no effect on the electroscope, or on the spark counter, but it affects both GM tubes. With these, Perspex does not affect the radiation. It needs lead to stop it. Source C and nearly completely stopped by lead. What about source D? It discharges the electroscope. It affects the spark counter. A piece of paper prevents this. It also affects the thin wall GM tube. And the thick wall tube, though somewhat less vigorously. With both these tubes, paper makes no difference. But lead does. D some of the radiation stopped by paper, and some by lead. There is another property which should be investigated, the deflection of these radiations by a magnetic field. If I put source B there, with the thin wall GM tube here, the radiation is prevented from reaching the tube direct by this lead block. A magnet on here produces nothing. Turn the magnet round. The magnetic field that way produces a deflection of the radiation over there. The same experiment produced no effect with source C, but showed a deflection with source D. Let's record those results. Now you see, we have a lot of information, and I would suggest that it would be a very good exercise to let the pupils decide for themselves what is the significance of these results, a piece of real detective work. And it may take some time, but they will come to realize that we had here 3 different types of radioactive source, with D a mixture of all 3. And in the process, they will come to learn a lot about radioactivity. As you will have realized, A is a pure alpha source, B a pure beta source, C a pure gamma source, and D is radium, which emits all 3 types of radiation. Of course, it would be nice to identify the alpha particles with helium nuclei, the beta particles with electrons, and the gamma rays with electromagnetic waves. But this is not yet possible in the classroom. As I said at the beginning, the sort of experimental work that I have shown so far is what we would advocate at the elementary stage.